Hi everyone. Um, we're gonna get started now. So before we get into learning about machine learning, to sign up for the Showdown Hackathon event, I'm gonna send the link the in the live lecture notes channel, and also I'm gonna send the Discord document. So there you can basically follow directions on how to join the Hackathon Showdown channel on Discord, and then you can start solving problems. Um, and just some specifics about the hackathon. First place wins $300. Second place wins 200, and third place wins $100. And today, after learning machine learning from Jacob, we're gonna solve some hackathon problems, which several teachers are gonna teach. And just a reminder that tomorrow there is no class, so enjoy your day off. And if you don't understand anything, you can always ask in the question and answer channel. And if you guys don't have any other questions, then I'm going to hand it off to Jacob for the remaining portion of the machine learning uh, curriculum.
Yeah, okay. So today we'll be finishing off machine learning. Let me share my screen. So today we'll be finishing up our last project. Um, and this is the iris flower classification um, project. And as you can see over here, there are three pictures of irises. We have the versicolor, the setosa, and the virginica. And the way that people classify these irises is that they consider these factors, right? The petal length, the petal width, the sepal length, the sepal width, and those values determine the variety. Right. So if you just look at these images, you can see that the petal lengths and the sepal lengths and the widths um, all differ, and based on those factors, the variety is determined. So this is once again, this is classification. If you remember from Teachable Machine, we covered the dog and cat classes. But this time around, we want to classify some iris flowers. So, oh, and recall from previous lessons, we did regression. So classification will look a little bit different. But yeah, so it's the same pattern as last time, the four-step pattern. I'll just repeat it again, but it's the prepare the data, create a model, train the model, and use the model. So the only things that change are we have to change our independent variable. And that's because if you look over here, I'll actually show you the CSV file. I don't know if you can see this. but the values in our CSV file are all strings, at least for our variety. And for our calculations, we can't have a string because they should all be numbers. So the way you solve that is you turn this variety column into something that looks like this, right? Or another way to put it is you want to turn this string value into a number value. And the way you do that is you represent it as three different numbers, right? So the Setosa has a value of 100, the versicolor has a value of 010, and the Virginica has a value of 001. Yeah, and then another difference is that for our activation parameter in our Y value, we we set the activation parameter to softmax. And when we compile our model, we set the loss parameter to categorical cross entropy. You don't really have to know what that means, but just know that when we are doing classification, you want to make sure to set this loss parameter to categorical cross entropy. And then for our purposes here, we'll also set the metrics parameter to accuracy. And those are the only differences. Everything else is the same step. So let's go to Colab. Uh, yeah, so I'll wait for folks to navigate to Colab. But once you go there, make sure to create a new notebook. And just in case you forgot, it's actually I'll just show you how it looks like. Go to Colab. It looks something like this, and then you want to click New Notebook right over here. So I'll post this in the question and answer. All right, so go to the website. I'll give like a minute. And then what you want to do is create a new notebook. Okay, hopefully found your way there. Let's start. Just in case you forgot, it's the same steps. You want to import TensorFlow, here, and import pandas, PD. This is our machine learning. Let me. This is the machine learning library. This is our data format. Data format. Okay. So make sure to put these import statements, and then as always, we run the code block. Okay. And then we want to structure it like how we structured it for the last projects, right? We want to do the 4-step method. So let's create 4 code blocks. What you do is you hover over at the bottom, and you press plus code. Let's do that 4 times. Okay. And then we'll label the first one prepare data. Second one is create the model. Third one is to train the model. And the fourth one is to use model. Okay. So we need this CSV file. So I'll also put this in question and answer. but make sure to copy that link, and you want to create a data path variable. So this is the same process for most of the machine learning we did here. So you'll probably know what to do from here. Um, but this is just review. Let's create variable called iris, and then we'll read this CSV file. We'll pass in the data path. Then to confirm that we stored the values, that's to iris.head, which will print the first 5 rows. Okay, it worked. And then, like I mentioned before, we can't have this variety equaling a string. So what we do, this is the new part of the project, is let's actually create another code block. I kind of want to separate everything. What we do is we set iris equal to pd.get dummies, and then we pass in iris. Right. And what this does, simply put, is it converts our uh, non or it converts our string values to integer or not integers to numbers. Right. And to kind of show how that works, we can just print the first 5 rows of the updated iris object and see how that looks like. You can see, let me zoom out a little bit. You can see the differences between um, this iris object and this iris object. You can see that the variety has been split up into 3 subcategories, and those are the setosa, versicolor, and the virginica. And you can see that each row corresponds to a specific variety. So for the case of the first row, the the variety is of setosa, and we know that because it has a 1 and a 0, 0 for the other columns. So make sure to add this. Right. And then when we create our model, oh, before we do that, sorry about that. We want to create our independent uh, dependent variables. So let me just print the columns. And right here. And it's good to know what our independent and dependent variables are. So I'll just create another code block. And our dependent variable will be our 4 columns. These are our independent variables. So I'll do this. Right. It's because the variety depends on these 4 factors. So that's why it's the independent variable. And then the dependent variable um, is or it's all the varieties. So let's copy that. Yeah. And then we'll print independent and dependent to check that it was successfully stored. Yeah. Okay. Let me go back. So for preparing data, Um, okay, now let me just. Okay, I'm pretty sure you got this part down because we've been doing the same steps. Uh, but I could explain this and this part again. So for this part, what we're doing, this method right here, get dummies, it converts our string values to numbers. And what I mean by that is when we have a variety column like here, you can see that the value for each column is a string instead of a number, right? You can see like for petal length, for example, these are all numbers, all floats. But then for the variety column, it's a string. And later on, that will mess up our calculations, and we can't have that. So that's why we convert our string values to numbers using the get dummies method from pandas, right? And this converts our string values to numbers. So it will go through what this method does is it goes through all the columns and it checks if there's a column that's not a number and it will convert it to numbers. That's a simple definition. And over here, you can see that it actually worked. If you compare uh, this iris and this iris, right? Or if you compare this variety column and these variety columns, you can see that this variety column was split up into three categories, right? So that's that part. The and for this part, the independent and dependent, what we simply did was we defined the independent variable as the four columns right over here because the petal length, petal width, sepal length, and sepal width, they all determine the variety. So like the whole point of our machine learning model is to predict which variety we get out of these three, right? So like the answer could be either Setosa, versicolor, or virginica. And in order to determine that, we need these four independent variables. Yeah. Okay. For your question, I believe make sure data path. If you define data path with an underscore, make sure it's spelled like that when you pass it in the read CSV method. Yeah. So there should be if you define data path as data underscore path, make sure that there's an underscore here too. And then for here, the dependent variables, once again, it's the three varieties that we're looking for. Okay, so hopefully that answered your question, Priyala. Just let me know if I need to clarify. Okay. Um, so we printed these and we found that they work. Right, the independent variable stored all our independent, like all our four columns, and our dependent variable um isn't not working. Should work. That looks right. Or oh, okay, yeah, sure. Um, so okay, so this we learned this last lesson, but I'll just quickly go over it. We create a data path variable and we set it equal to the URL of the CSV file. So you got that part down, right? This is our path to our CSV file. And then we create an iris variable. So this iris variable stores all our data in our CSV file. It stores it in a single variable, and we use the read CSV method from pandas to read the data. Right. So that creates the iris variable, and then this iris.head, it prints the uh first five rows. So that's why there are five rows printed. So hopefully that answered your question. Okay. Uh, let's move on to the next step. Right. So we created our independent dependent variables. Let's create our model. And here's the step. We want to create our X layer. There's dot layers input. Then we set it equal to 4. And why do we set it equal to 4? That's because we have 4 independent variables. So shape of the layer is 4. Yeah, okay, good. Um, right. So once again, the X layer, right, our input layer has a shape of 4 because we have 4 independent variables, which are the petal length, petal width, sepal length, and sepal width. Our Y layer, on the other hand, looks a little bit different. It has 3 outputs, right? The first argument right here is 3 because we have 3 varieties, the Setosa, Versicolor, and Virginica. And make sure that for this particular problem, for classification, that we set activation equal to softmax. Softmax. Right? Activation equals softmax. And then we write it in terms of X. And in case you forgot Y, it's because we can represent Y as a function of X, like so, which is why we do, or we write Y, the Y layer like this. Okay. So this 3 right here, 3 or 3 outputs. Okay, so we have 4 inputs and 3 outputs. Right? So that's the X and Y layer. We create our model. So we create a model variable. We set it equal to layers. Oh, not layers, sorry. Models, model, and then we pass in X and Y. Right? This just creates an instance of a model, our machine learning model, and then we have to make sure to compile it. Okay. And then, like I've mentioned before, we want to change our loss parameter to categorical cross entropy. And we want to set our metrics equal to accuracy. All right. And these parameters are only for classification problems, right? Before, if you remember, we didn't do all of these. That's because that was a linear regression problem. So for classification problems, you want to use this loss parameter and this metrics parameter for now. Okay. So feel free to copy that down. I'll leave it like this while I'm typing number 3. Yeah. And then everything else is the same process. So we call the fit method. We pass in our independent dependent variables, which we defined back in over here. We define our epochs, or the number of times our machine will train. And obviously, the greater the number of epochs, the more accurate your model will be because it would have trained more. So let's do 1,000 for now. And then make sure to set verbose equal to 0 so we don't get 1,000 print statements. And then let's train the model 10 more times, but make it visible. Okay, so I'll run this, and then I'll run this. So this will take a while. Okay, so if you look over here, you can see that there's the loss value, but also this new value, which is the accuracy. So if the loss is something that we want to get as low as possible, right, as close to 0, we want the accuracy to be as close to 1, right? So this tells us how accurate our machine learning model is, right? So you can see that the loss is actually pretty low, so that's pretty good. And then the accuracy is pretty close to 1. So I don't think we have to train it anymore. So let's leave it at that. And let's go right into predicting our values. So we'll go ahead and do print model.predict independence. And then we'll compare it to our actual values. Okay, I'm gonna go ahead and that's way too many values. So I will print the first 5. Right. This is how we pick the first 5 values of independent, and we'll do the same for dependent. Okay, let's kind of see what's going on. So we can see this e right here, by the way, is means 10 to the power of, right? So if you look over here, you can see that for the first row, the actual value is 100, right? But if you look at what our machine learning model calculated, this basically right here is pretty much 1, right? This is roughly 10 divided by 10, which is 1. This right here is pretty close to 0, and this right here is pretty close to 0. So that means for this one, it worked pretty well. And then likewise for this row, you can see that this is roughly 0 if you do the math. This is around 1, and this is around 0. And that matches with this row right here, right? It has a value of 0 for Setosa, a value of 1 for versicolor, and a value of 0 for Virginica. So you know that the value, or this right here, it successfully predicted that the variety would be versicolor. Okay, so that's how you interpret um, these results. You kind of have to do a little bit of math, but it's kind of obvious that um, which ones are equal to 1 and which ones are equal to 0. Yeah, and let me know if you want me to explain what this means. But I'll just write it over here. E means 10 to the power of. Right, so for example, if we have 9.987 e negative 0.1, the same thing as saying 9.987 times 10 to the power of negative 1, which is basically saying 9.987 divided by 10, which is pretty much fun. Yeah, so that's the math over here. Okay. I'll leave my screen like this. And then I guess I'll answer any questions if you have any questions right now. But I'll leave my screen like this so you can copy everything down. Okay. If not, then that basically wraps up our machine learning lesson. Um, yeah, this is our last project. We don't have any more projects, but yeah, thank you for having me. Uh, that's basically it for me.
Hi everyone. Next we're gonna go to the hacker rank problems. Um, so there we have a list of problems that we're gonna explain in order to prepare you guys for the. So several teachers are gonna take turns explaining several problems. Um, so yeah, I think Elliot will go first. Um, yeah, we're gonna explain a couple problems.
Alright, I'm gonna wait for everyone to click on the link. I can wait a minute. And it should send you to this link right here. And I'm gonna help you guys solve the first 4 problems. And is there an echo here? It's gonna be the first problem we're gonna try. Alright. An echo is when your sound waves bounce off something, come back to you, so you hear yourself saying what you just said. An echo is a sound wave. Okay, so it says to create an echo program, and we have to, the first line of the file will contain a positive integer t, denoting the number of test cases that follow. Each test case will have the following input. Okay. Just like this, we have the number of test cases, and we have 1 and 2, and it should echo back, or essentially just print out twice. So that's just what we're coding. And we can write our solution here, right? So we can start with our number of test cases, so we can make that as input. So we can just call that variable t. and we have to make it an input, but let's make sure to cast it as an integer, right? Because it's a number of inputs we need, right? Input. So we can have t equals int input. Okay, and we need to loop through the amount of test cases. So we can just call that I. So for I in range, we can say in t, x equals input. And what this does is whatever we type here, right? And now through that, we have to make that x print out twice. And to do that, we just do this. And we can run our code and it's show no errors. If we also submit our code, our test case should work. Do we have any questions on the first problem? If not, I'm going to move on to the next problem. Alright, so now we're going to do add apply. And pretty much in this problem, you deal with the concept of addition and multiplication. Your task is to write a program which does simple addition and multiplication based on two input numbers. Okay, so first line will contain a positive integer t denoting the number of test cases that follow, and each test case will have the following input and a single line containing two positive integers separated by a space. Okay, and the numbers will be small enough that they will not be bigger than integer max value when multiplied together. So here we have the number of test cases. We have the number of. Can you repeat? Yeah. I don't know if the code saves. For this problem, I'm assuming the first one. So the problem wants us to have a number of test cases, 1 and 2, and each test case they want us to write whatever writing twice, right? Just like an echo. So what I did is we have a variable t counting the number of test cases, and we're going to loop through each test case. Okay, and we have something called line, okay, or I think it was x, but it doesn't matter. X, you can have this as any variable, and we have that as an input. What do we write? And we're just gonna print that out twice, like an echo. So if it's code quest rules, we're gonna make that output twice. Does that clear up your question? One, two, one. So this one's same thing, the amount of test cases. We have two numbers separated by spaces, right? And it's gonna show the addition and the multiplication. For this one too, 5 plus 4 is 9, and 5 times 4 is 20. So it's gonna be separated by spaces. Okay? So what we can do is this one's pretty simple as well. We can make the number of test cases as well. T equals int input. Okay, now we gotta loop through each test case for I in range of t. And we have x equals input for whatever we write. Okay, and now we're gonna be doing something called, we're gonna split it. Okay, so we can call that like parts equals x dot split. Okay, so since it's two numbers, we wanted to split the values, and what it essentially does is, let's say we have 2 and 2. It's gonna show up as a list, like a substring. 2, 2. So just like this as two separate values. Okay. And now we have to have two parts, right? We have two numbers. So we can call that A and B. So A can be, or we can have something called add, and that'd be equals, or no, we gotta call A equals int. And since this is index 0, index 1, we do int parts 0. We can make B equals int parts 1. Okay. So we're casting the substring, right? Because we don't want to be in quotes, we want it to be an integer. So this would just become 2 and 2, A and B, and we can make a variable called add, which should be just A equals A plus B, like mult equals A times B. And if we print it out, we can have it print out like this. And what this comma does, it just makes a space for our print statement. And that should work. Yep. And I'm gonna submit our code. And yeah, it should work. Do you guys have any questions on this problem? Not, I'm going to move on to monogram. So monogram, our task is to write a program that takes a full list of full names and outputs a list of monograms in the correct format. Okay? So every name given will contain the first, middle, and last name separated by a single space. Sometimes an initial will be used instead of a spelled out name. And traditional monograms are presented in first, last, and middle initial order. And monograms should be printed in all caps. So if it was like Franklin Roosevelt, right, we have, right, just in this order. We just want to take out the middle, initial, and last. Okay, first, last, and middle order. So it'd be F, R, D. H cross P would be H, P, R. Okay. And the first line will contain positive integer T, denoting the number of test cases that follow. So just like we did last time, we can make a variable for the test cases, and we can call that T. Just like that. And we can loop through that. And we can also just have an underscore if you don't want to call it anything in range of T. We have n equals int input. So what this does, it reads the number, right? We have two test cases, but we have two names, right? And four names for here. So this is the input for the amount of names. We gotta loop through each test case first. All right. Okay. So now in range of n, right, we can have a variable called name equals input, which is gonna be the names. And we can split each name to first, last, and middle. And what we can do is have a variable called parts equals name dot split. We're gonna use that method again. It's gonna show into a substring. And we can have a variable called monogram. And we can initialize the monogram first without writing anything in. And now we have to add the first character of the monogram. So we would do monogram plus equals parts 0, 0 dot upper, right? Because the output needs to be all uppercase. So this is going to be our monogram for our first name. Okay. Now we're going to add one for the last name as well. Plus equals parts b2. And now this is for the first name and last name. And now we have to add one for the middle name. We have to check if the length of the parts is greater than 2. Because some won't have a middle name, but if it does, then we'll add the middle name monogram. So plus equals parts 1 0 dot upper, and we're now gonna print the monogram. So if we run our code, we should get no errors. There, line 16. Now, oh, this should be inside this for loop. So that should work now. Supposed to be inside this for loop. Okay. Fine. Oh, line 29. Oh, right. My bad. So now it should run. There we go. Do you guys have any questions on this? Make sure you got an indent on each statement. If not, I'm going to move on to some things missing. So our task is to write a program which a given string and an integer will print a new string missing the character at the given place. Input format, we have a T denoting the number of test cases, and a single line containing a word, then a space, then a positive integer. The integer tells us which character to remove from the string and is zero based. The index given will always be valid. Okay? So right here, we have a sample input, and we see our index of 0 is missing. Okay, so that's just what we're going to code. We can start off with the number of test cases. And now we can loop through the test case. So inside, we can make two variables called word and input, or index. So word and index. We can do it by doing this. Okay. And we have to make that an input dot split. So we got to separate them. And we can have index into an int. So you don't want it to be a string. And we can make a new word, right? We have word, and now we can do, let's say, new word equals word index plus word. So what that is I'm gonna take out the index from the word. Okay, and now we just need to print the new word. And if you run the code, it should have no errors. You guys have any questions? If not, I can pass it on to the next speaker.
This number square board 5, 5 across, 5 down, one side, across 3 by 3 square. Once this program this five that equal. So question.
Justin,
Oh, my
um,
audio not.
yeah, your audio hasn't been working for the yeah.
Oh my God, sorry. Um, okay, so I guess I could just go over this again. I already kind of typed out everything, but I could explain it. So I'm just going to start from the beginning. We get n test cases, and for each test case we get a number, which basically means the size of the square that they want us to print out. So in the first case, 5, we have a square made out of hashtags that is 1, 2, 3, 4, 5 across, and there's 5 rows of the square. And same with the other square made out of 3 pound signs across and down. So we want to make a program to print these out for each test case. So the first thing we read is n, the number of test cases, and for each test case we read an a, which would be the size of the square that they want us to print out. So inside here we would need nested for loops to generate the shape. So by row we basically make s, which is basically like this. So in another for loop that basically iterates the size of the square a number of times, we would add to s, making it 1 longer, 1 longer, 1 longer, 1 longer, 1 longer, and then finally printing out s, and we would do that 5 times for the first case and 3 times for the second case, which would make all 5 or 3 of the rows. Sorry, this might be the wrong problem. Second, I think this might be one of the later problems. Okay, sorry. So this is the problem I was supposed to go over. So change digits. So we are given a positive integer, as here. We find the largest digit out of the positive integer, and if there's more than one digit with the same value, then we would just take the first one that shows up in the number. And if that digit is odd, we would change it to 0. If that digit is even, we would add 4 to the digit. And if the sum is greater than 9, we would change the digit to the digit in the ones place of the sum. So let's say in the case of 8, 8 is even, so we add 4 to 8, we would get 12. But since 12 is greater than 10, we would take 12 and only keep the 2 out of the 12, and you can see here the 8 turns into a 2. So each input will be a positive integer less than 100,000. And we're only getting one input per problem. As you can see with 923, 9 is odd, so we change it to a 0, but since leading zeros get chopped off in the code, it's only 23. Okay, so this is, I like to change the n, which is an integer, into a string n, and then I would like to change that into a list. And basically what this does, I think we might have done this before, but it just makes it easier to go through each value in the numbers, so I split it up into all the digits. And so I would have max equals 0. So we're going to keep basically track of which value is the biggest value. And then I'll have max in, which short for index, equals -1. And this will basically be the location of the biggest number. Then for I in range 0, comma, len, n. So I'm just iterating through the list. Equals int ni. So this is the current number that we're looking at. So we would go look at 1, we would look at 8, we would look at 2, etc. And if a is greater than max, if we find a new biggest value, then we would set max equal to a and max int equal to I. Since I is our current index, max int would always be the position of the biggest number. So in sample input 0, that would be 1, since it's 0, 1. And 8 is the biggest number out of all of those. And then after that, we need to check between these two cases, is the digit odd or is the digit even? So if int and max int, so the digit at the largest digit of the list, not the list, the integer, then %2 equals 0. If it is even, then what we need to do, and max int equals string. Since we converted this to a string list, we need to have this as string type. Then int and max int. So this is kind of a lot that's going on right now, but 1 second. Set 10. So basically, we're taking the value of the biggest number, we're adding 4, and then we're doing modulus 10 on it to remove any 10's values and keep only the 1's values. So remember, like we had the case with 8 turning into 12, and then we chop off the 1 at the beginning. So that's just why we're having the %10 here. And we're converting it all to a string since this is a string list. And else, if it is odd, then this is a bit more simple. We just convert this, the location of the biggest number, into 0. And then we return. Since we changed this to a string list, we have to convert this back into integers. We would return int, then dot join n. And what this does is basically just put each item of the list next to each other, so it converts it back into one whole number. So if I run this code, it should pass the test cases. And if I submit this, it passes everything. Okay, and any questions? If not, I'll pass it to our next speaker, Taeyong.
Hi everyone. I'll get started. Yeah, I'll get started with the next problem. Okay, so we're gonna go over the problem asterisks. So I'm gonna read the problem and then I'm gonna go over some of the sample inputs, and then I will start to code. So, given a figure type and its size, draw the figure using asterisks. The output will have a maximum size of 80 characters across and 22 characters down. Input format. Each line will contain a letter denoting the type of figure, and either one or two integers denoting the dimensions of the figure. Input formats for each figure type are as follows: S, comma height, H, comma height, L, comma height, or B, comma length, comma width. Constraints: the type of figure will be either S, H, L, or B, and length is between 0 and 80, and height is between 0 and 22, and the same goes for width. Output format: print the figure of the stated size using asterisks. So the sample input that they give us is S, comma 3, right? And if we look at the input format above, for S, they only give you the height. And in that case, you're going to print out a square, which is 3 by 3. Sample input, the second sample input has H, comma 5. And in that case, you're going to print 5 asterisks and then 4, 3, 2, 1. If you have L, comma 5, then you're going to do the opposite of what you just did before, which is just 1, 2, 3, 4, and then 5. And last, we have B, comma 4, comma 5, which means we're going to have 5 rows and 4 columns of asterisks. And yeah, so those are the 4 cases of input formats that we can have. So I'm going to start to code the solution. Let me just copy and paste the Okay. So I'm going to start coding the solution. So the first thing we want to do is we're going to take the input and then we're going to split the input using the method by the comma. And what that's going to do is it's going to store a list of the character and then the dimensions or the integers that come after the character. And after we do that, we're now able to refer to these different letters and integers separately. So I'm going to create another variable and I'm going to call the first one first element type, because the first letter indicates what shape that the figure is going to take, right? So we're going to have an if-else statement ladder. So the first case is if type is equal to the character S. Look above. If the character is S, then we're going to have a square, which means if they give you like a number, it's going to be that many asterisks and that many for rows and the same number for columns. So the way you would print that out is for I in, so we're going to use a for loop. And then we're going to take the second element from our list here, because that number is going to specify the size of our figure. So I'll write this code down and then explain it. Okay, so what this does, this for loop is basically going to iterate through, it's going to iterate 3, or so for in this example, we have S, comma 3. So our second element would be 3, right? So if that's the case, then we're going to iterate through the for loop 3 times. And each time we iterate through the for loop, we're going to print this asterisk 3 times. Because if you remember in Python, if you multiply a string by an integer, then you basically repeat or print that string that integer number of times. So that's how you would take care of the case for when type is equal to s. And then we have elif type is equal to h. We're gonna use another for loop here. And in this case, since we're going from 5, 4, 3, 2, 1, we're decreasing. We're gonna still use the range function, but this time we're gonna have 3 parameters, and the reason is this first number specifies the number that we want to start from, right? And this is the number that we're going to end, except we're excluding that number, right? And the third parameter is going to describe our steps. So basically, -1 would mean that each time we go through the for loop, the number would decrease by 1. So if we were to look at this case, since the second element is 5, it would go 5, 4, 3, 2, 1. And it excludes 0. So since we have that now, we're going to print the star. Or actually, we have to be careful here because we're not just printing asterisks here. We're also printing space in front of the figure. So you also have to print the spaces. So the number of times you print the space is the length of, or how many asterisks are in each row, subtracted by the current number that you're on, which is I. Because let's say we're on this row and we're currently on the number 4, right? So we would have to do 5, which is the whole length, minus 4 to get the number of spaces. So that's that. And then we would have to concatenate the remaining part of the figure, which is just simply the asterisk times I. That would print the case for when type is equal to h. We still have 2 cases left. So elif type is equal to L. We're also going to use a for loop here. And if you recall, for L, we're going in the opposite way. So we're going from 1, 2, 3, 4, and then 5. So here we can just do 1 comma int chars, the second element, and then +1. And what this is going to do is it's going to go from the numbers 1 through this -1. So it's going to go from 1, 2, 3, 4, all the way up to this number here. And since we have that, we're simply just going to print that times I. And then we should just get this figure, this triangle figure. And then after that, we have our final case, which is when the type is not S, H, or else, so we can just use else. We're also going to use a for loop here. And in this case, in this case, we have two numbers here for when the letter is equal to B. And our third number is going to tell us how many rows there are. So that number is going to be how many times we iterate through the for loop. So that's why we do range of int chars2. And each time we go through a loop, we're going to have to print the asterisk this many number of times. Because this second number, or the first number here, second element, is going to specify how many stars or asterisks are in each row. So that's why we multiply it by this number. And yeah, this should give us, so as you can see, it passes all the sample test cases. And now we're going to submit the code. Yeah, so it passes all the test cases. Does anyone have any questions for this problem? Oh, sorry, I didn't see this question. I don't exactly understand what you mean, but if you want me to explain, I'll explain this part again. So basically, so I'm gonna go back. So when the letter is H, so when the letter is H, we're gonna go from 5, 4, 3, 2, 1. So we're decreasing, right? Number of stars is decreasing. So what we're gonna do, so since it decreases, we're gonna use the range function. We have to specify the parameters of the range function in order for the numbers to actually decrease. So basically, the first parameter is always the number that you're starting on. The second number, or the second parameter, is always the number that you're going to end with, except it excludes that number. And the third parameter, which we don't usually use, but we can in this case, is describing the step. So since in this case it's -1, it means that with every iteration of the for loop, so every time we go through a loop, the number is going to decrease by 1. So let's say it was -2. Then this means that the number would go down by 2 each time we go through a loop. So now we're able to specify the number of stars that we want in each row, right? And then for the print statement is also kind of complicated, but the stars aren't the only thing that we want to print here. We also need to print the space before the stars, because if we don't, we're actually going to get a different figure. So we need to print the space. And the way we calculate the number of spaces before the stars is we subtract the length, which is just 5, right, by the current number that we're on. So let's say we're in the middle row. Since the whole length is 5 and we're on the number 3, the number of spaces would then have to equal 5 minus 3, which is 2. So that's why we multiply the space by the length minus the number that we're on. Then we concatenate this with the stars multiplied by the number that we're on. So hopefully that answers your question. I'm gonna wait a little bit. Okay, seems like everything is good now. I'm gonna pass it on to Jacob for the next problem. Sorry, that's my bad. Yeah, I think time is up for us today. We weren't able to go through as many problems as we wanted to because of some technical difficulties at the start. But we're gonna continue the day after tomorrow with the rest of the problems. But for today, that's gonna be it. So if you guys don't have any other questions, you guys are all free to leave. Oh, and just a reminder that there's no class tomorrow.